Alright, let's do this. We're watching every type of engineering in 8 minutos. Actually, before it starts, I want to guess. At least, I'm trying to think of like the main ones I remember. So, obviously I can see some here, but I'm only going to name the ones that I remember from college. I think the ones that were offered were aerospace. I started as a civil, so civil switched to mechanical. So, aerospace, civil, mechanical. There was electrical. I didn't like electrical. I like to mess with electrical components, but I didn't like doing the math for it. Materials, hated materials. It was boring. Computer science. Not the biggest fan of coding, but I do it when it's necessary. And I think we had a computer engineering major as well. Other than that, I think there was a environmental engineering as a minor, not a major. And I think that was it. Yeah, I think that's about it. So I have my bachelor's in mechanical. Currently doing my master's in mechanical as well. Not to go too deep into it, but I'm trying to figure out what my specialty is going to be in. It's either probably going to be in robotics and controls, or in some type of like design and manufacturing. So if you're in a similar spot, let me know. We can figure something out together. But let's watch the video.
Engineering. Aerospace engineering is a field of engineering that focuses on the design, construction, and maintenance of vehicles that travel through air and space.
Yeah, so if you get aerospace, you want to work at Lockheed or like Boeing or Northrop, and you're gonna make money. But I mean, you're gonna make money. That's all I can say. I'm not jealous.
It is divided into two main areas, aeronautical engineering and astronautical engineering.
Yeah.
Aeronautical engineering deals with aircraft that fly within Earth's atmosphere, such as airplanes, helicopters, and drones. Astronautical engineering, on the other hand, focuses on spacecraft that operate outside Earth's atmosphere, like rockets, satellites, and space stations. Agricultural engineering.
For you guys who don't have too much experience in engineering, keep in mind though, a lot of these intertwine. You can be a whole different major and do a lot of the same things. Like there's a lot of mechanicals who work at aerospace heavy industries, like the ones I mentioned, like Boeing, Raytheon, stuff like that. I think they even mentioned like drones. Like I've done some drone work, and obviously not an aerospace engineer. So
agricultural engineering
never heard of this one. I feel like this is probably like a sub branch of environmental engineer, but.
This is on improving farming techniques and machinery to enhance food production. It combines elements of mechanical, civil, and chemical engineering to design agricultural equipment, irrigation systems,
okay, I guess that makes sense, but I've never heard of a
agricultural engineers work to make farming more efficient, sustainable, and environmentally friendly. Biomedical engineering. Biomedical engineering is a multidisciplinary field that applies principles and techniques.
Yeah, I know a lot of mechanicals who go into biomedical. Not for me, but I can see how it could be very rewarding, money-wise, obviously, but also just kind of like fulfilling, like you're working on things that are meaningful, so that's great.
Techniques from engineering, biology, and medicine to solve problems related to healthcare and improve patient care. This can include creating medical imaging systems, designing artificial organs, developing new medical instruments, or working on cutting-edge research in tissue engineering and biotechnology. Chemical engineering. Chemical engineering involves converting raw materials into useful products through chemical processes.
I was terrible at
Chemical
chemistry,
engineers design and operate plants and machinery used for large-scale manufacturing. They work on a wide range of products, including fuels, pharmaceuticals, plastics, and food. They also focus on sustainability by developing processes that reduce waste and energy consumption. Civil engineering. Civil engineering deals with the design, construction, and maintenance of physical and natural built environments. This encompasses a wide range of infrastructure.
So basically, if you know what the word civilian means, it's anything that has to do with the civilian. So, like the houses, the apartments, the roads, anything transportation-wise, like dams, anything along those lines, that's a civil. Or in other words, or at least what we mechanicals like to joke about, anything that doesn't move is a civil.
Projects, including buildings, roads, bridges, airports, dams, and water supply systems. Civil engineers work on projects from the initial planning stages to their completion, ensuring that structures are safe, sustainable, and meet the needs of communities. They consider factors like materials, environmental impact, cost, and regulations to create function.
Sorry, I know I'm pausing a lot, but Another thing I want to say is I get a lot of people who ask me like what's the difference between a civil and a architect. I can say at least I'm more on the civil side. I can't talk too much about what an architect does, but the way I think about it is an architect is like the artistic-ish side, or at least more of the artistic side. Like they do the drawings, and then the civil is the one who does the math to tell you whether or not that drawing you built is actually gonna be able to be possible or if it's gonna tumble and fall. So that's what the civil does.
And resilient infrastructure. Computer engineering.
Computer engineering is. I can't say I really know what they do, to be honest with you guys. I hear computer engineering, I think software, but at the same time, that's also the same thing I think of when I hear computer science. So I don't know. I guess we're about to find out.
The field that combines aspects of computer science and electronic engineering to develop computer hardware and.
That's like the worst combination of two engineering branches. But I mean, if you like it, go on ahead, man.
Software. Some universities refer to this field as computer science and engineering. Computer engineers need to be skilled in various areas, including electronic engineering, computer science, hardware-software integration, software design, and software engineering. This discipline applies techniques and principles from both electrical engineering and computer science, and it covers areas such as artificial intelligence, robotics, computer networks, computer architecture, and operating systems.
Okay, sorry.
Electrical engineering. Electrical engineering involves the study and application of electricity, electronics, and electromagnetism. Electrical engineers design and develop electrical systems and equipment, from small microchips to large power station generators. Their work is critical in many fields, including telecommunications, power generation, and consumer electronics. Industrial engineering.
I have no idea what an industrial engineer does, to be honest with you guys.
Industrial engineering is a branch of engineering concerned with how to make or do things better. Industrial engineers design systems that enable people and society to improve quality and productivity, while at the same time cutting waste like time, materials, money, and energy. Industrial engineers make sure your mobile phone fits in your pocket while still having a lot of processing power and also not overheating. Or they can make sure it won't burst into flames while you're flying on a plane. Materials engineering. Materials engineering blends elements of physics, chemistry, and engineering to understand and manipulate materials at the atomic and molecular.
Yeah, materials is boring to me, man. I like to think of it as like the engineering where you study dirt. Yeah, I know it's an oversimplification. You gotta do a lot more than that. But to me, that's basically what it is.
Levels. Materials engineers study the structure and properties of materials, such as metals, ceramics, polymers, and composites, to develop.
Like, it's cool, but like, is it? It's like what's like a completed project for a materials engineer? It's like, oh wow, look at the great foundation I built, and then someone makes a building over that. It's like at least the civil can see the building. The materials, what? It's like, oh, awesome foundation I made. Don't get me wrong, like I respect it, but it could not be me.
Materials that are stronger, lighter, or more durable. They also play a crucial role in advancing technology, such as creating more efficient batteries for electric cars, developing stronger yet.
Are the materials engineers in charge of batteries? I thought that would be more of like a. I feel like a mechanical does that, or maybe like even. No, I guess that makes sense, or maybe even a chemical. I used to work with batteries, and I was not a materials engineer.
Lighter materials for airplanes, and inventing new materials for medical implants that can better integrate with the human body. Environmental engineering. Environmental engineering focuses on protecting the environment by reducing waste and pollution. It involves designing systems and solutions to improve air and water quality, manage waste, and mitigate the impacts of human activities on the natural world. For example, an environmental engineer might develop a water treatment facility to ensure safe drinking water, or create plans for a landfill that minimizes contamination of surrounding areas. Mechanical engineering.
The goated engineering right here. This is the jack of all trades and the master of all.
Mechanical engineering is one of the broadest engineering fields, focusing on designing, analyzing, and manufacturing mechanical systems. Mechanical engineers work on everything from engines and HVAC systems to robots and medical devices. They apply principles of mechanics, thermodynamics, and materials science to create efficient.
See, we do everything. Why do we need all the other engineering branches? We got it.
Efficient and reliable machines. Petroleum engineering. Petroleum engineering is a field that.
Petroleum. You ever seen Deepwater Horizon? You blame these guys. Not really, but it's still a great movie to watch.
involves the exploration, extraction, and production of oil and natural gas from beneath the Earth's surface. Petroleum engineers play a crucial role in finding new sources of oil and gas by studying geological formations.
They got the engineers with the hard hats. They ain't doing anything. They're behind a desk. Calm down. They don't need no hard hats.
And employing advanced technologies like seismic imaging. Once a potential
seismic imaging? Have I been saying it wrong this whole time? I swear it's seismic, right? Is that just me?
reservoir is identified, they design and implement techniques to extract the resources efficiently and safely. This can involve drilling wells, using pumps or other methods to bring the oil and gas to the surface, and managing the extraction process to maximize production. Petroleum engineers also work on developing new technologies to improve extraction methods and minimize environmental impact. Marine engineering. Marine engineering involves the design, construction, and maintenance of ships, boats, and other marine vessels and structures. This field encompasses everything from the engines and mechanical systems that...
Like maybe this would be something more like in the military type thing, like the Navy, Marines, obviously.
power these vessels to the structural integrity and safety of the hulls. Marine engineers ensure that these vessels are seaworthy and efficient, working on a wide range of projects from commercial ships to submarines and offshore oil platforms. Geological engineering. Geological engineering combines principles of geology and engineering to solve problems related to the Earth's materials and processes. This field involves studying rocks, soil, groundwater.
Okay, it's basically just like materials. It's like a branch of materials. See, they literally admitted it. They study dirt
and other natural resources to design and construct safe and sustainable structures. For instance, a geological engineer might work on projects such as building tunnels, designing stable foundations for buildings, or managing natural resources like minerals and groundwater. Textile engineering. Textile engineering focuses on the design and development of textile materials and products. This field covers everything from fibers and yarns to fabrics and finished garments. Textile engineers work on improving the properties and performance of textiles, such as making them more durable, comfortable, or resistant to stains and water. They also develop new manufacturing processes and innovative textile products, like smart fabrics that can monitor health or change color. Acoustical engineering. Acoustical engineering is the study and application of sound and vibration. Acoustical engineers work on controlling noise and improving sound quality in various environments. They might design quieter machines, improve the acoustics of concert halls and recording studios, or develop noise control measures for urban areas. Their work ensures that sound levels are safe and that audio experiences are optimized for clarity and enjoyment. Optical engineering. Optical engineering involves the design and application of optical systems and devices, which use light. This field covers a wide range of technologies, from lenses and microscopes to lasers and fiber optics. Optical engineers might work on developing better cameras, creating advanced medical imaging equipment, or designing systems for transmitting data using light. Their work is crucial in fields like telecommunications, healthcare, and manufacturing, where precise control of light is essential. Nuclear engineering.
Whenever I see nuclear, I just think of that YouTube guy, the nuclear engineering guy. People are always like joking that like he, one way or another, always brings up that he's a nuclear engineer. But I mean, that's his channel, man. That's what he's proud of. I would be proud of it. So I'm a mechanical. I'm gonna start doing that every episode.
Engineering, the field of engineering that deals with the science and application of nuclear and radiation process.
Another good movie, well, at least for me, Chernobyl. I think it's a movie, right? Or maybe it's not a movie. Well, it's something that happened in history that has to do with nuclear. If you guys are ever curious, maybe search it up on YouTube. It's pretty cool. There's other examples. That's just, I think, probably the biggest one.
These processes include the release, control, and utilization of nuclear energy and the production and use of radiation and radioactive materials for applications in research, industry, medicine, and national security. Food engineering. Food engineering is concerned with machinery and equipment that come into direct contact with foods, as well as those that provide essential services in food factories, such as refrigeration, air conditioning, steam and hot water generation, water treatment, waste treatment, and electricity generation. Knowledge of the physical properties of foods is an essential part of food engineering. Packaging systems are also key to a food engineer's role.
Oh wow. Okay, cool. That was honestly a great video. Okay, cool. That was honestly a great video. It was like straight to the point. I gotta admit that like half these I'd never heard of. I feel like there's like the major sectors of engineering and there's like the sub branches of that. Overall, great video. Honestly, if anyone has questions about engineering, more specifically mechanical, but even just in general, I feel like I've been around engineering for some time now. I've experienced a little bit of everything. So if you ever want to talk, shoot a comment. Let me know what engineer you want to be or engineer that you are, and we can connect, man. Have a good one. Yeah.